Okay, so in this problem, there's a mass hanging on a string, and it's 5 kilograms. And there's 35 newtons of tension in that string, and kids get all freaked out about tension. But tension is just force exerted by a string. Okay? Strings always pull. Strings always pull. And so when we talk about the tension here, we're talking about an upward force. Okay? And so generally when a mass is hanging on a string, there's an upward force due to the tension. I could imagine a situation where I could actually pull downward on this, but I don't want to do it because I would like smash a hole in the floor. I would have to actually pull this thing down and accelerate it down faster than 9.81, wouldn't I? Yeah, I could do it. I just don't want to demonstrate that. Okay, I'll do that later when we get to circular motion. We'll talk about that, right? But there it is. So the upward force is 35 newtons, and the answer is not 7. Okay, if you've gone 35 divided by 5 and gotten 7, right? The answer is definitely not 7. Why is it not 7? Is 35 the only force acting on it? Yeah, there's also the force of gravity, correct? Yeah. So when I say solve for and / label all the forces, suffice it to say that there's one more force. If it's hanging and it's on Earth, right, then there's a force of gravity downward, and that force is equal to, well, it's m times g, right? So it's 5 times 9.81, and that's 40. Yeah? Yeah, you could do that. Shh. Can we be quieter? So the weight, the force of gravity is the weight. Weight is m times g. We've done this before, haven't we? A bunch of these, right? So 5 times 9.81 is 49.05. Somebody said, shouldn't you make it negative? Sure you could, right? It really is going to be negative in the scheme of things. I was going to leave it positive and then say it's down, so therefore it's negative. Either way it's negative, right? So this guy's positive. I'm clearly going to make up positive, down negative, right? And now I'm all set to solve this, right? I'm going to go 35, a positive 35 minus 49.05, and then that equals 5 times a. And of course, what do we know? We know it's not going to, not only is it not accelerating up at 7, it's actually accelerating downward, because the force upward is not enough to prevent it from accelerating down. The force is less than its weight. That's the weight, that's the mass. The force upward is less than the weight, so it's going to accelerate down. Does that mean it's moving down? Do we know that this thing is moving down? So I get negative 14.05 is 5a. Because kids will always say that. They say, oh, it's got to be moving down. Okay? Yeah, that's right. I don't need to see it on a whiteboard necessarily. Okay? Why could this thing, how could this thing be possibly moving upward? We know for sure that the acceleration is going to be, if I just divide, the acceleration is negative 2.81 meters per second squared. But how could it possibly be moving upward? Like, say it's already moving up, and what's it doing? Slowing down and stopping. So if you're moving straight up and you slow down, aren't you accelerating downward? Because if you accelerate upward, you go faster and faster. If you slow down, you're accelerating downward, yes? Okay? So, yeah, for sure we know that the acceleration is downward, but we don't know anything without knowing more about the situation, whether it's moving up or moving down. So resist the urge to say, oh, it's moving down. No. That means that it's accelerating down, but it could move either way. It could very easily, it could be going down faster and faster, or it could be going up slower and slower. They're both downward accelerations, correct? Now, in an elevator, don't you feel that? Yeah, you do. If the elevator is accelerating down, don't you feel, well, in this case, there was less tension in the cable holding it than there was equal to the weight, right? In other words, there's less tension than there was weight. Okay? In an elevator, what it is that you feel less force on your legs. You feel less pushed against the elevator than you weigh normally, yes? You feel lighter when the elevator accelerates down, don't you? Yeah. That's kind of fun, isn't it? So what do you do at that moment? Jump. You jump. You either jump when it starts to go down, or when it stops moving up. They both work. Yes? Yeah, well, I did test this. I always do this. I'm a physics teacher, right? So whenever I'm on a fun elevator, I always jump. Now, the joke is that, of course, white guys can't jump, right? Okay? But I can jump. I can jump on an elevator that's accelerating down. Okay, I'm at this conference. I think it was an IB conference. This is like the ultimate of nerdy things, right? I'm alone in the elevator, and the elevator stops moving up. It's coming to the floor. I'm riding on the elevator solely for the purpose of jumping. Are you picturing this? I jump. White guy rams his head into the ceiling of the elevator. It's such an aggressive elevator that when I do jump, I smash my head into the ceiling. And I'm standing there like this. When the door opens, I'm like, you know, I'm doing like, am I bleeding? That thing, like you hit your head so hard, you always got to check, right? You know, right? And it was bleeding, but not like really fast, not like a gusher, right? And I'm like, there's a little bit of blood on my hands. And the guy, a sort of plump fellow with a big suit on and a briefcase, chose not to get on the elevator with me. It was just like he kind of looked and was like, there's somebody bleeding from a scalp wound. I'll take the next elevator. You know, kind of a thing, right? Elevators are funny situations like that, right? So you can try that. Try it when it starts to go down. Try it when it stops moving up. The first warning is don't ram your head into the ceiling of the elevator because you will be able to jump unusually high. And the second warning I'll give you is don't get 4 of you on an elevator jumping, because 4 people jumping, that's quite a lot of mass moving around, and you can actually cause the elevator to reset. I mean, don't do that on purpose, because the joke's on you. The elevator shuts down and you're caught in the elevator. Okay, and basically the deal is this: elevators, they really, really don't want to open the doors when they're not at a floor, because people might walk out into the elevator shaft and they go all the way down. The elevator shaft goes all the way down. Have you ever seen one open when they're working on it? They're frightening places, right? You never see them on purpose, right? But if the elevator ever like isn't where it thinks it should be, there's little sensors where on the motor and everything like that. It senses where the floor is, and if it ever is not right at the floor when it thinks it should be, it just shuts down and lets a human figure it out. And the human might be an hour away. Right? They'll call somebody up to service the elevator. Meanwhile, you're waiting on the elevator. It's not that funny, but you know. So just be careful. Don't get 4 of you to jump all at once. That's not quite as much fun, you know. Yeah. 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 Did you shut the elevator down?
We're just there for like 5 minutes.
Yeah, there you go.
Like, what are we gonna do?
That's what that little bell is for. Ring, ring,
We were
right?
there, like,
You know?
okay, we were trying to figure out like what we should do. We found, we should like call somebody and start again. We're like, okay, immediately.
So this is an extra credit opportunity if you'd like to do this. Okay? If you would go on an elevator with a scale, shouldn't you be able to tell the scale's going to read more or less than your weight? More when you're accelerating up, less when you accelerate down, yes? Shouldn't you be able to figure out the acceleration from that? I'm thinking you should be able to with the stuff we're learning here, right? You ought to be able to figure that out. Okay, so that'd be worth extra credit if you could figure it out to actually take a scale. I think you'll have the elevator to yourself, right? So take a scale in there and weigh yourself and look at the thing. You might want to bring a camera and film it, and wouldn't that be a good video? Especially to get people's reactions when they see somebody filming themselves on a scale in the elevator. I don't know, right? But you should be able to figure it out, properly done. And I could help you with the calculations if you can't figure it out, but it should be pretty simple. Okay, so yes, accelerating down.